Morning, everybody. And I'm very appreciative of the crowd because in spite of the fact that it's a Sunday morning, all of you have come and adjusted to my schedule, and therefore it's really nice to see all of you today here. There are three components of the lecture today. The first one is regarding the structure of a computer. You must have seen that after all, we are dealing with a machine, and the most interesting way of learning a machine is to open it up. Okay. Frankly speaking, I would like you to take a machine, or I will request my colleagues who are dealing with the lab that at least you should open up a computer and see physically what is what actually. So when you are running the program, it looks like abstract and it looks like as if something is happening like a jiffy. It's not something which is so abstract, it's physical, and it happens, electronics happens at a very breakneck speed, no doubt about it, but it happens physically. So what is a computer is the first question. Okay. The second question that I want to pose to you is, what is a program? After all, in order to interact as the humans and the machine, we have to have some mechanism of interaction, and obviously that interaction is through a program. So the next question that comes up is, what's a program? And the third part of my lecture today is regarding the introduction or a background of some problems that I want you to take it up as the homework. I will of course send you the email details regarding the problems, etc. But I will also explain to you so that you know what you are expected as a homework. Okay? So these are the three specific things, and then the next lecture we will go further and then close this discussion, and then following that there will be presentations and the discussions, and my colleagues will start lecturing on the Python language, which is the language we have now selected for you. And as I told you that some of your friends in other colleges may tell you that, oh, never heard of this language, why are you not learning C, why are you not learning Java? And you have to tell them that go and read Economic Times, because in Economic Times there was a very big article that the highest salary for a programmer being paid in India is to that programmer who is a Python programmer. So if you are looking for a good job, learn Python. Obviously there are many languages and you can learn all of them, but even learning one language good is good enough. Okay? So you will find over the years, as I mentioned earlier, there are variety of computers, and nowadays in fact the things have become very mind-bogglingly confusing. But the basic hierarchy of different kinds of computers, one is that you have got tablets, or you have got iPad for instance, or you have got a laptop which could be a Lenovo, or it could be a Dell, or it could be an IBM, or it could be a Toshiba, or it could be Samsung, or it could be any of these laptops. Opening them up is very difficult. Opening even the iPad is very, very difficult. But obviously what we will try to do is to keep some machines in our labs, open them up, and you can see them actually. You can literally see where is what actually. It's very easy to open up a desktop. So the second thing is the personal computers. These were like the dabbas, the desktop, about 6 inches height, and then maybe about 18 inches by 24 inches, there used to be a box. And you have a CRT based display screen, and we will put that on the top of it. Obviously it used to be very bulky. And nowadays in fact the things have changed to such an extent that you just get one kind of a piece which has got the screen, and the back of it is the whole computer actually. So you call it as one single screen computers. And nowadays most of us, when you use the desktop, you don't use that big dabba, and sometimes that dabba is also available at the bottom. In fact, before you came to the classes, these rooms were used by Tech Mahindra for their associates, and a lot of those desktop computers were around in these rooms as a matter of fact. So personal computers are essentially the desktop computers, and I'm going to show you in some sense what is the structure. If you take any one of them and see what is the structure, elements are the same. You have to have memory, you have to have a CPU, you have to have a disk drive, you have to have the controllers for the input-output peripherals. All these things have to be there. So how they are accomplished in different versions is the essential difference. But we will see all of them. Then there was a workstation. As I told you, that PDP-11 was a workstation, or there were other workstations. Basically, the difference between a workstation and a personal computer is that the workstation was far more powerful, the disk space was far more, and typically for engineering work, if you are doing some structural analysis of a bridge, or if you are doing some structural analysis of an aircraft frame, or if you are doing the fluid solid interaction of the hull of a ship, for instance. Now these are very large problems, so large problems that the disk space that you require, the memory that you require, the interaction that you require, the kind of graphics that you require, and the kind of output devices that you require, maybe sometimes the networking with a large computer that is required. So the features wise, the workstations were different, and even today you will find that some people still continue to use the workstation, though the boundaries have become now so blurred that what was available 30 years back on a workstation is now available to you on a tablet. So you will find that the obsolescence in this field has been very rapid. If you are using a machine for 3 or 4 or 5 years, you will find after 5 years that machine becomes obsolete. And therefore, if it fails or if it has got some hardware problem, it's very difficult to repair, and most of the times what you have to do is to throw it out. In fact, there is something, as you have got this garbage collection problem, the biggest garbage that is produced in the world is the electronic garbage. And you will find that collecting this electronic garbage and disposing it off is very, very big problem. It may look trivial to you, but believe it or not, it's a very serious problem, because most of the computers have plastic, and plastic is biodegradable. So obviously there is a big problem of how to dispose of this plastic, which is the electronic part. Then there are some chips. These chips have got silicon in it. And silicon is a very expensive material. As a matter of fact, the soldering of those tips that are to be done at many places in the computers used to have earlier the gold material and then put the soldering. So I was in charge of the computer center at IIT Kanpur, and then we had junked some old computers, and then we put the advertisement, and one fellow came. He is called as a kabaddi. You know, kabaddi is all these fellows who take all the used material. And he specialized, some Shah from Bombay, he specialized only in computers. He says, I only take junked computers. And why? I said, how you make money? He says, I take out the chips, and then the rest of it I melt it, and I collect gold out of it. And the gold is very expensive, and he says, I sell the gold and make money. So you will find that there are very difficult issues related to the electronic garbage that we are creating out of these computers and peripherals, and unfortunately the life of it is not very large. Then you have got mainframe computers. The mainframe computers, as I told you earlier, is essentially, nowadays they are called as data centers, or they are called as the enterprise computers. Tech Mahindra, for instance, they will have a huge computing facility at some place, and that will be called as an enterprise computer. And all the operations, all the transactions, all the computations are done on that machine, and it is connected either through the wired connection or through the internet connection, or many other things. Actually, I will talk about it very shortly. So this is like a big machine, and some of the pictures I show you to you. But the processing of it is not as powerful as it is for the top of the end, what is called as the supercomputers. There was a company called Cray which started the generation of the supercomputers, and there is a Indian organization. We were not allowed to import the supercomputers, so the country decided to have our own supercomputers, and the first one was the Param supercomputer, which was developed by CDAC. And today even you will find that CDAC continues to develop newer and newer versions of supercomputers. The supercomputers and the mainframes, you will find the difference is supercomputer is more compute intensive. When I want to solve huge problems, let's say weather forecasting, if you want to do the weather forecasting, the kind of data sets that you have to handle is huge. And then you want to do the parallelization, you want to have many nodes. Each computer or a subcomputer is called as a node. So you may have a 500 node machine, you may have a 800 node machine, and you will find every 6 months the top 500 supercomputers in the world are published. India has got 2-3 slots there. Sometimes we don't come up, sometimes we are there, but you will find there are large supercomputer installations throughout the world. University of Illinois, for instance, has the largest supercomputer station at one time, and these rankings go up and down. But essentially for scientific work, you will find workstations and supercomputers. For business transactions, you will find that the enterprise computers, personal computers, and for all our ordinary folks, it is the tablets or the laptops that we use.